Hello, good morning and good evening. I am Atsushi Koyama, second year student of master course in the Department of Civil Engineering, the University of Tokyo. My submission number is 1228 and my presentation title is Governance Rules for Logistics Service Providers in the Era of the Physical Internet. I am so happy to have an opportunity to share my research with you. Today, I will talk about logistics, especially about the future of logistics. There is an emerging logistics concept called the physical internet. It is an interconnected global logistics system and is expected to greatly improve logistics efficiency. Yet, there is a lot to discuss for the implementation of this concept, and they can be classified into two domains: management of assets and stakeholders, such as fee collection or avoiding oligopolistic situation, and technological development, such as developing a new container standard or developing ICT infrastructure. And this presentation will focus on the management of assets and stakeholders. Then, this is the contents of my presentation. First, I will briefly explain what logistics is and the challenges it is facing. Then, I will talk about the concept of the physical internet, or the PI, what the PI is, how it emerged, and what projects are currently going on around the world. In the third section, I will discuss the possible problems in the PI. Although it is a great concept with great possibility of solving logistics challenges, they are so novel that there are some uncertainties for stable supply of logistics services. So I will summarize possible problems which have been pointed out so far, and if solution or direction of solution already exists. Finally, in the fourth section, I will focus on one of the problems which has no solution or direction of solution yet. I will tackle the problem of possession and maintenance of infrastructures and fee collection scheme. Here I will refer to the cases in train transportation and electrical grid. So first, I will give you a brief explanation about logistics, because I think not all of you are familiar with this field. According to Wikipedia, logistics is an act of managing the flow of goods between the point of origin and the point of consumption to meet the requirements of customers or corporations. It is important to note that logistics and physical distribution are actually not the same. Logistics means management of whole supply chain from procurement and production to transportation and finally selling and even returns. On the other hand, physical distribution is just about transporting things, and it has six main functions as listed here. In this presentation, I use the term logistics, but my main focus is on the part of logistics, or is on one part of logistics, physical distribution. And I think it is easy to imagine how much our modern lives are depending on logistics. Everything we eat, everything we wear, and everything we use in our daily lives are supplied through domestic and international networks of logistics service providers. And in the era of COVID-19, we are using e-commerce more than ever. However, the logistics is showing multiple unsustainability symptoms. For example, Montreal, one of the first exponents of the physical internet, suggested 13 unsustainability symptoms in 2011, which includes we are shipping air and packaging. Empty travel is a norm rather than the exception, or truckers have become the modern cowboys. Then, let's look at what these statements mean by checking the situation in Japan. The load factor in Japan has been declining for years and is below 50%. Load factor shows what percentage of available capacity was actually used. So this means that tracks are running more than half empty. And this is exactly what Montreal meant by stating we are carrying air. Also, the annual working hours of truck drivers are about 1.2 times higher than all industry average. And this is what he meant by saying truckers have become the modern cowboys. In order to treat these symptoms, the physical internet was advocated around 2010. The physical internet is an interconnected global logistics system enabling seamless asset sharing and flow consolidation. The idea of the PI comes from the internet we use in our daily lives. Just as information are divided into small packets and transported through a network of networks, objects are encapsulated into small containers and transported through a network of multiple transportation companies. This slide shows the difference between the current logistics system and the physical internet. Currently, most logistics are dedicated networks or independent networks. As shown on the left, one truck carries product from only one shipper, and another truck carries product from a different shipper. Therefore, it often happens that the truck capacity is not fully utilized. However, if we connect these two networks and use only one truck instead, in other words, if we share the assets and consolidate the flow, its capacity will be fully utilized. This is the basic idea of the physical internet. But of course, this is not a novel idea. There are so many cases in which retailers, such as convenience stores, work together with its competitors on cooperative logistics. However, these cases are limited in terms of amount and diversity of goods and geographical area. The uniqueness of the PI is doing this at a far larger scale, like in a country or even in an international level. And expanding such interconnected networks to a national or international level requires three important components: containers, hubs, and protocols. Connecting multiple logistics networks means tremendous number of transshipment at hubs. If we try to do this as we are doing now, I mean by forklifts or even by hands, it will take really a lot of time and will lead to increase in cost. Therefore, every transshipment must be automated. This will be made possible by standardized Pi containers, automated Pi hubs, and protocols defining the rules of transshipments. Pi containers will be designed to be easily transshipped at completely automated Pi hubs, and optimal route and optimal carriers will be chosen for each Pi container by a Pi platform, which works according to the protocols. So let me summarize a bit. This slide shows important features of the physical internet, which distinguish the PI from current logistics system. At a conceptual level, the PI is characterized by asset sharing and flow consolidation, and they will be realized by standardization, matching in a platform, and data sharing at a technological level. Then, this is a brief history of the PI. The first paper on the PI was published around 2010, and an organization called ALICE, which stands for Alliance for Logistics Innovation through Collaboration in Europe, was established in July 2013. This organization has taken initiatives in many PI-related projects. Some of them are listed here. For example, Moduruska was a project aiming at the standard development of containers for FMCG, fast-moving consumer goods. And in Japan, the Physical Internet Realization Conference was established last year. Each organization has published a roadmap in 2020 and 2022, respectively, and showed the steps towards the realization of the concept. And these are the roadmaps published by two organizations. Although there are several differences, both aims to realize the physical internet by the year of 2040. However, looking at these roadmaps and projects shown in the previous slides, I found that although there is enough discussion on technological development, discussion on management of assets and stakeholders are left behind. Considering that the relationships among stakeholders will become more complicated as the PI is characterized by asset sharing and flow consolidation, this point needs tackling. Especially as the logistics is an essential infrastructure, logistics service should be provided stably, both in transition period and after the implementation of the PI. So I have set my research question as how should stability of logistics service supply be secured as logistics become more complicated than ever in the PI? And to answer this question, I will define logistics performance that should be provided stably and clarify the problems that threaten stability of the defined logistics performance in the next section. And finally, I will propose a solution for one of the problems. In order to define the logistics performance to be secured in an organized way, I read several papers and documentations on logistics performance. And I noticed that most papers looked at the logistics performance from perspective of customers or shippers and not from logistics itself. They are like how the logistics service quality for customers should be defined or how logistics performance affects the performance of organizations. On the contrary, the Logistics Performance Index by the World Bank was made from the perspective of logistics itself, but I found the components for the index are too abstract because the index is designed for the international comparison. Therefore, I decided to reclassify the indices mentioned in them according to corresponding functions of logistics, as in a table here. Maybe you can understand this table as translating abstract functions on the left to the concrete indices on the right. The most fundamental role of logistics is to fill the gaps of space and time. Transportation time, punctuality, and geographical coverage correspond to this function. Then, as our daily lives is heavily dependent on the logistics, accessibility to and certainty of logistics service should be included in the basic function, and low cost, low damage rate, reliability, and resilience will be their performance measure. At last, usability is also an important function, and this can be translated as traceability, number of options, or the ease of using service. And considering that the logistics is an essential infrastructure, this logistics performance must be secured without interruption at a sufficient level and sustainably in the transition to and after the implementation of the PI. Then I read through discussions in Physical Internet Realization Conference in Japan and had interviews with PI-related institutions to clarify the possible problems which might threaten logistics service stability. And then I classified them according to logistics performance each problem can affect. Also, right column shows from which PI characteristic the problem stems. And in this table, I added the sustainability of the whole system and the logistics industry itself at the top. Of course, it is important to note that each problem affects several functions at the same time in reality. Let me explain some of the problems. So for example, looking at the yellow rows, asset sharing, which means facilities become like a public goods, can lead to lack of maintenance or investment, or can be regarded as violating antitrust law without adequate development of laws. It can also cause unclear allocation of responsibility and lack of fair access to facilities if shared assets are not adequately operated. Then, the introduction of platform that supports smooth asset sharing and flow consolidation can cause oligopoly or monopoly by network externality effect. Also, complicated and frequent negotiation between stakeholders can take time and make the transportation time longer. And of course, PI-related organizations have discussed these problems, and some are already being worked on, and direction of what to do have been shown for others. However, there are still some problems left behind in these discussions, and they are highlighted here. And in this presentation, I will work on the problems of investments, maintenance, and fair access to facilities. In order to find a solution for this problem, I decided to refer to cases in two other industries, train transportation and electrical grid. So an important difference that stems from asset sharing is that the asset currently possessed and managed by each carrier or shipper will be run by the platform. This causes a problem of who and how to manage the assets. More precisely, who is going to do the maintenance, who will pay for the cost, and will fair access to facilities be secured for all carriers. And two industries, train transportation and electrical grid, have dealt with similar problems. The EU has tried to promote free competition in train transport in the region and introduced open access and vertical separation of train infrastructure. And in electrical grid in Japan, the possession of and management were separated to enhance neutrality. What these two industries are trying to do, or the underlying objective of these measures, are first, management by an adequate body and fair access to facilities, and second, collecting enough fee. And these are exactly what the PI should achieve in sharing assets. First, I will talk about the management of assets. In Europe, each member state will determine its domestic policy complying to EU directive. And directive in November 2012 requests each country to provide every train service company with equitable, non-discriminatory, and transparent conditions and right to access the infrastructure. It also requests separation of infrastructure manager and service provider and preparation of neutral allocation body. And two types of managing structure can be found in Europe to comply with this directive. Countries like Sweden have independent infrastructure manager that also allocates infrastructure capacity. On the other hand, in countries like Ireland, infrastructure manager also provides train service, so they have another independent allocation body. Then, in electrical grid in Japan, the separation of possession and operation of transmission and distribution is going on to improve neutrality. Generation and retail were deregulated and open to any private entities, but for avoiding overlapping investments and securing stable supply, the government chose not to make it an open market. And this is a trend in the world, and there are several ways of separating possession and operation, as shown on the right. The easiest way is to separate the account. But to further ensure neutrality, some countries are establishing a holding company and legally separating transmission and distribution as a new company. Also, in some states in America, they separate the operating function to an independent operator. Then, considering the characteristics of logistics, which way of infrastructure management best fits a PI? Logistics infrastructure are mostly owned by private companies and by a great number of companies. There are more than 60,000 tracking companies in Japan, although not all of them own logistics centers. Therefore, it will be difficult to completely separate infrastructure manager and service provider. So basically, an independent operator, like one in Irish Railway or electricity in some American states, will be required. But this will not be easy, considering another important feature of logistics, the relationship between platformer and pi hubs. In train transportation and electrical grid, independent infrastructure manager can both plan and actually operate by itself. However, in the PI, platformers who plan transshipment will not or cannot take responsibility on actual operation in each pi hubs because they are owned by a great number of entities. So my proposal goes like this. What each company does is to separate account for its logistics service and pi hub management. Then, in order to secure the neutrality at actual operation, evaluation from users, I mean service providers, will be effective. This is because unlike current logistics, service providers who are not in a close relationship with PI hub manager will use pi hubs. Of course, the way of evaluation needs discussing because everything will be done in an automated way. And at a more formal level, supervision from platformer should be done, of course, but this will not be enough considering the number of pi hubs. Finally, let me move on to fee collection. Going back to train transportation in Europe, we can find several trackage definitions, and they are well summarized in Ozawa 2013. He classified them by demand level, how much the government wants to promote entry of service providers, how much the government can afford the subsidy, and if multiple service providers will use a rail. And the very basic idea here is that marginal cost will be lower than average cost, and lower trackage will attract more service providers. Then, what about the logistics? If the PI is fully implemented, we can say that the demand is enough. However, at an early stage, demand will be still low, and the number of participating countries will be small. Another important characteristic is the company is the industry structure. It is said that 99.9% of tracking companies are small and medium-sized companies. For them, two-part tariff can be an obstacle to enter. So my suggestion is that preparing a trackage system for the early stage and for the mature stage. At an early stage, the cost paid by users should be low enough to promote entry, maybe lower than the average cost, and the rest should be supplemented. Of course, this does not necessarily be subsidy from the government, as it might be difficult for them to justify that. Instead, I think shippers or real estate developers who own logistic estates, of course, along with logistic service providers, can establish a fund, because perhaps will be used by every stakeholder. Then, after plenty of number of players participate in, maybe they can move to one-part tariff. As I said, 99.9% of trucking companies are SMEs, so two-part tariff can be a big burden for them. And the important thing here is that transparency. As a logistics is an essential infrastructure, the costs should be well checked, and fees should be neither too high nor too low to threaten adequate investments. And at last, this is a summary of my presentation. Logistics is an essential infrastructure, but not sustainable. The physical internet is expected to improve logistics, and the PI is characterized by asset sharing and flow consolidation, standardization, and platform. Yet there are several problems that can affect stable supply of logistics service in the PI, and a solution for some problems can be found in other industries. And these are the references. Thank you very much for listening.